Okay, are you seeing the full screen at this point?
I am not
Or
seeing
am
any
I
shared screen.
Okay,
Right now, we're seeing the words "a share screen share is being started." Good morning.
okay, that's wonderful. Well, that
Morning,
looks
John.
even worse.
Oh, wow.
There we go.
Cool.
That's actually a good
Is it,
sign.
does that mean it's going toward it or not? No, that doesn't. Okay, does that change it to full screen or not?
Nope, not
That's your
yet.
slides.
Pardon? Do you see slides?
Yes.
Okay, once I do that, I can't see the rest, but uh, I will get to present slides, it looks like. Okay, I don't think Data Tracker allows me to get in and look at this twice. I've got another machine. Is it the full screen setup, Jeff?
You have a slide being shared in the middle of a larger window.
Okay, that's the um, is that better or worse?
Worse. You've reduced the
If you
content.
check, so in the upper left, there's a view menu. The view menu may have an option to have a, let's see.
Fit with? Okay,
Yeah, no, it doesn't really do it.
doesn't really help at all. Okay, that's
I
my
would just
best.
roll with what you got there. That seems adequate.
Okay,
And we are at the top of the hour now.
Yep. So I'm not going to be able to see the participants monitor. Jeff, it appears that the way that I can do this is roll the slides. So you and Kayer will probably need to do the remainder. Let's see if I can get in a second way.
So while we're waiting to get the slide stuff taken care of, if anybody wants to run a quick microphone check, that would be a good time now.
Testing the mic.
Oh, my shoe.
Philippe, we can hear you.
Thank you.
And I'm pretty sure I heard Randy too.
Oh, I saw Randy as well.
So how about this? Does this work?
Alvaro, you're good.
Yep, thanks.
And John, you sound like you're talking to the room rather than to a headset.
I will drop and reconnect.
Hi, Jeff. This is Kariraj. Do I sound okay?
A little quiet, but we can hear you.
Okay.
That should sound like a headset now.
That sounds great, John. And since we're waiting on Sue, let me go ahead and try to share my slides, see if that's any better.
Clap,
How
clap,
does that
clap.
look?
Full screen. It looks full screen.
So, Sue, if you actually are still listening. Sue, your microphone is currently not active.
And Sue was offline, it says.
Well, it wouldn't be an IETF without some sort of technical problems first thing in the morning.
It's all part of the fun.
Video is now active. And again, since we're waiting on everybody to finish joining, this is a good time if you want to run a quick microphone check for you to do so. Hi, Sue. You seem to be back. Your microphone is currently on mute.
Yeah, I just muted it again. Thank you.
Thank you, folks.
So, Sue, I'm able to display full screen. If you want me to run the slides, I can do so.
Okay, why don't we go with that? There's always fun with backup. My problem was tried a second connection. Bad choice. Okay, folks, I will go with the slides. Did John get a chance to say hello for his last moment as IDR chair? Okay. As you well know, go ahead with the next slide, Jeff. You find that we have two new co-chairs, Jeff and Kara. There's handsome pictures for both of those. And Alvaro wanted a few minutes. So Alvaro, you're in the queue. Are you around, Alvaro?
Oh, sorry, I was on double mute. Good morning to everyone, or actually good afternoon because we're supposed to be in Prague this week. As Sue said, I want to also welcome the new co-chair. Some of you should know by now, or know already by now, that John has been selected as the new routing AD. Even though he's still listed here in Mileco as IDR chair, his official functions started yesterday as AD. The official turnover, of course, happens on Wednesday, so this is the last time that we're going to see him as IDR chair. John, I think you're all going to agree, has done a great job over the last few years as IDR chair. He had some big shoes to fill in. He surpassed any expectation that anyone ever had. And so much so that, of course, IDR and BGP have grown so much with him and Sue in charge of the working group. We have 4 or 5 different working groups working on BGP. And now we decided to add 2 new chairs so that we can handle the amount of work. IDR is the busiest working group in the IETF. That means it has the most number of drafts active and in all kinds of states. There's a big list that you saw this week. That is just a small part of what we're going to discuss this week. So I want to, again, thank John for all his work. It is going to be a pleasure and an honor serving with him as area director. And welcome both Keir and Jeff as the new co-chairs. Just one last thing, I have to unfortunately go on to a different meeting that I'm also responsible for, where I'm the AD. So John is going to fill in for me here. As I said, his duties started yesterday. So thank you and welcome.
Thanks very much. I won't say a whole lot except to say thank you for being such a great working group, and to Sue for being best co-chair I could possibly ask for. It's been one of the highlights of my career.
So just in case you all have, Jeff, if you go to the next slide, just in case. Next slide, Jeff, if you get, next slide, just in case you want to make something fun, John, we're sending you off with a little IDR gift, which is for your tea or other beverages. There'll be a high-tech coffee cup delivered to you. But going for that, to fit on the bottom of that cup, it plugs in. It's one of my husband's fun cups. And the battery tells you when the cup will stop providing automatic heat. We're going to make little cup caddies for John's cup. So I've ordered a whole bunch, and I have a friend who will put little vinyl pieces. So if you want to send a message, otherwise John will get something inspiring for me, such as thanks as being a co-chair, or some of the RFCs that he's joyfully either written or provided shepherding for. So if you have one, just send me a note. I'll put your message here. And we just a way of sending John into his AD sleepless nights with coffee and our concerns. Jeff, if you go to the next.
Thank you very much. When I'm drinking my third cup of coffee, it'll at least be hot.
Yes, that's the point. My husband likes it as he goes on. So the note well is something you should notice. If you haven't read it, take time to read it or go to the IETF page. Next one. And we should go with our first presenters, as I'm still a few minutes late. Jeff, you're the first presenter.
Thank you, Sue. So I'll try to actually keep things moving at a fair pace for the first two presentations. So in this respect, I'm speaking as one of the members of the IETF IDR BGP auto configuration design team. As Warren helpfully put in the slide view, this is a long name. So the design team was kicked off during IETF 106, basically over breakfast, to talk about what are we going to do about auto configuration for BGP. The topic has been sort of a hot one in some circles, specifically in the context of trying to actually make data center BGP a lot easier to run. The working group was, the design team was spun up in January 2020 to put together the requirements and solution space. This was partially in response to a number of drafts people had put out covering different aspects of auto configuration, and the design team's charter is to figure out what do we actually need to do for the working group. As sometimes happens in IETF work, the work stalled and we kicked it off basically again fresh in January 2021, and we've been meeting at a good pace since that point. It's worth mentioning that here's the current design team members, and we owe special thanks to Randy Bush for doing the initial work, for putting together the core of the document that we have extended since then. So the critical decision for the design team was to focus specifically on BGP auto configuration for data center purposes. It was within our discussions of BGP auto configuration for other contexts, not specifically to solve that problem for other situations. As an example, for PEC controllers, or for ASBRs, or for talking to route reflectors, but to make sure that if we're going to pick something that is useful for data center purposes, if it's extensible for other purposes, that it can be done so. And our determinations largely match that. For the most part, the contents of auto configuration that the design team discussed is that we do need support for v4, v6, potentially both, potentially neither. It depends on exactly how you want to do your BGP. The example 4/6, 4, etc. We do need the support both peering directly at the interface level and potentially for loopbacks. There are, for example, IBGP flow fabric topologies that do peer over loopback, and therefore need some help with bootstrapping forwarding to get things up. We need to pass around enough state inside of whatever the protocol is to help us figure out what the endpoints actually need to get a session up for BGP. That not only includes IP addresses, but includes things along the lines of authentication or transport security, like TCP/AO, TCP/MD5, IPsec. Things like GTSM are configuration parameters that are needed for TCP to come up appropriately for these things. And for some implementations, BFD configuration needs to be clear and set up before the session ends up being able to come up. Now, obviously, there's information that BGP also needs to carry around. So it has things like the AS number, the AFI-SAFIs. Clearly, these things are present in the BGP open message. The information really here is to decide, do we want to open up a session? And to some extent, that also includes things like a device role. Device roles are intended to be hints for the selection process to allow a BGP speaker to decide, do you want to peer with this thing? In many cases, for common situations we're trying to cover for data centers especially, some of these roles will be well known. So for example, in your place in the topology, if you are a leaf node on a 3-layer flow fabric, you only really want to talk to aggregation layers as an example. So responding to auto configuration for another leaf or for the spine layer would be inappropriate. And that said, well, there are probably several well-defined roles that we can actually define. The majority of these were likely to be set aside as private and to be allowed to be used in the machinery for an operator for their own purposes. Once we have enough information to decide, do we want to peer with this thing, BGP basically takes over. We have enough information to bootstrap the TCP session and we're ready to go. One of the requirements that we did discuss is that some operators do not actually want BGP to bring up the session itself. There was a desire for a validation mode where effectively the manual configuration, if it was conflicting with the stuff via the discovery protocol, the implementation's capable of actually raising an alarm to the operator and they can decide what they want to do about that. So this allows, in many cases, validation of expectations versus configuration, and just as importantly, allows people to override auto configuration if it doesn't make sense. One of the more extensive conversations, which does impact what IDR decides to do next in terms of selecting protocols, is where does the protocol actually run, layer 2 or layer 3? There are use cases for both of them. A lot of our discussion was that layer 3, probably in some flavor of multicast, like the all routers multicast group as an example, would probably suit the majority of use cases that we're looking at. The challenge becomes when you're plugging into something that might be a switch-like device. There's a good chance that your broadcast domain or multicast domain in this case is actually larger than you're expecting. And sometimes the expectation is you really just want to peer with the thing that's on the other side of the port. If you're doing something that resembles multicast or broadcast, potentially that's much further across the fabric than you're really expecting. So this does mean that there may be cases for restricted layer 2 unicast or multicast. So we published the draft. I misnamed the draft as I mentioned on the mailing list. And part of the next steps are have the working group review what the design team's come up with, decide that this is actually what we wish to carry forward, and we're looking for feedback on the contents. Once we've actually gone through an iterative cycle to figure out did we actually do our job correctly, the job of IDR is to discuss what the next steps are for actually either picking one of the existing proposed solutions and filling in the holes that the design team has identified. Alternatively, we may decide that as a working group, do we need something that is not in the proposals to date? So we have a small amount of time for questions. I've got us up a little bit. So Robin, go ahead. You'll need to click on the microphone icon.
Hello, Jeff.
Hi, Robin. We can hear you.
Okay, Jeff. I have the two questions. One question is about this scenario. You mean that this the scenario for the BGP auto configuration focus on the data center network. Is that is this one or not?
That's the critical thing that we were doing our work for. It was our determination that we could probably support other non-data center scenarios with the same machinery.
Okay, but even for the data center network, you also have some the specific limitation or some this constraint. I mean that the span leaf architecture data center network, or maybe other data center network with different topology.
Certainly the main scenario that we were thinking about was the standard Clo fabric type topologies, but in other type topologies such as butterfly, etc., it's our belief that the BGP state that needs to be passed around by the discovery protocol probably will be the same. Very likely the role information as to how you discover what your adjacent neighbors should be in the topology would potentially go in there. And that's where the next steps are. Did we get the state necessary in the protocol correct? And do we have enough information to support in a more general fashion discovery for various topologies?
Okay. My second question is about the layer 3 and the layer 2. I'm a little confused about the switch fabric. Do you mean that's the MAC switch or the VLAN switch? Is that the switch fabric?
Well, to pick an example, a lot of layer 3 ports that you may plug into may be actually carrying information from one port to another across something like EVPN as an example. So since there's really many extra devices in the middle, what is your trust level about IP multicast in those types of environments? It's the experience of several people on the design team that multicast for IP across various types of switching technologies sometimes ends up being a little bit strange. So we wanted to make sure that for circumstances that you want to talk to a known device that is directly on the other side of the port, that a layer 2 option is present. And we have 2 drafts that are discussed in the design team requirements that have been published that talk about layer 2 solutions.
Okay. Okay. Thanks. Okay.
Thank you. I should.
To ask one question. For the operation of the BGP auto configuration, we must configure the peers information in advance. And also the role of each device. So I think if all of them have been configured, the BGP configuration work. The work for the BGP configuration is there is very little thing to do for the BGP configuration.
So your observation is correct. Depending on what you're looking to use auto configuration for, I'm sorry, I can get a little bit of feedback from your microphone, Asian, if you could mute, please.
Yeah.
When you're getting auto configuration being done, it depends on what you're using auto configuration for. In some cases, people are looking to just avoid having to do IP address configuration as one of their use cases. But in other use cases, perhaps you actually have a device that you literally take out of a box. It is expecting that it's going to be going into a BGP Clo fabric, and you plug a port into another device, and it just automatically joins, at the appropriate place in the topology. So you're correct that you can use this for very lightweight, just for avoiding IP address configuration and managing all the TCP properties, all the way to devices coming out of the box that know exactly what they're supposed to do.
I think if the auto configuration work can auto configure all the related information. For example, the S number or the PO address, and then I think it can ease the deployment of the BGP in the within the data center. If we need configure all these things, then I think the most part of work has been finished. Okay, so the
Hey, Jun, your microphone cut off, but to talk about what I think what you're heading towards is the design team's document is not intended to address 100% of the picture for configuring a device that speaks BGP. So this is auto configuration for bringing up a session. You're correct that if a device needs to learn its own properties, things like AS numbers, etc., that's a bigger piece of auto configuration for the device that may fall under other ZTP type work, zero touch provisioning.
yeah. Okay, I know. Thank you.
Again, I think we're actually out of time with you, so what should be the last question?
Hi, can you hear me, Jeffrey?
We can hear you.
Yeah. So, just a question. I guess most vendors, I guess, have some type of auto provisioning. Well, not necessarily auto provisioning, but a zero touch programmability, I guess, built into their architecture. So, I'm guessing this mechanism would be something that would play into that, but it would be like something that you could put a box out and just be able to provision, but work in conjunction with a vendor, particular vendors like built-in, I guess, auto provisioning capability.
Absolutely. So, one way to visualize this is that your ZTP mechanism for bootstrapping the box programs things like AS numbers, what the role is supposed to be. But even in those environments, you're expecting that you need to hear something from the other side of the wire to know what you're talking to is an acceptable device to peer with before you bring up your peering session.
Gotcha. So it's probably that first layer, I guess, that happens, really that discovery layer, which is probably the more complicated and the logic related to the discovery. I guess that's really the key part of the auto provisioning. How do you discover what I should be and what my role is, I guess. And that's probably the biggest one. Once it discovers it, and then it can actually go through the next layers. So probably to help with that first layer, the discovery layer of the vendor auto provisioning, I guess. Makes sense. That makes sense. And as you said, I think this is probably first application at data center, but there's no reason why you couldn't use this in really any application, I would think.
That is my personal hope, at least.
Right. Okay. All right, very good. Thank you.
Thank you again. And what we are likely to do as a follow-up is, depending on interest that we see on the mailing list and discussion, chairs have discussed that perhaps we will have a interim set aside for taking this work forward. So, in just getting ourselves continuing back on time, I'm going to move to the next presentation. So this is moving us into the flow spec portion of today's presentation. I'm taking the first one. I'm going to be talking about some flow spec extensibility issues in general and a proposal maybe to address some of the deficiencies we have today. So we've just gotten done a huge amount of work taking 5575 to RFC 8955. Thank you to Christoph for driving that work. This was Christoph's first heavy piece of work in IETF, as best I know, and it certainly took longer than I think he was expecting. Definitely thank him for the work that he's done on that piece. The problem that we have is in flow spec, based on the format we started with, packet rules are serialized into BGP NLRI. The format that the authors chose at the time was largely type value. And for anything that was some flavor of variable length list, the length portion is implied rather than explicitly made known. So the analogy is just like MPLS label stacks. You don't know how long the label stack necessarily is. You just know that it has an end of stack bit. With flow spec components, in many cases, there's some flavor of end of list bit for the operator. This does have a negative consequence that you really can't safely parse flow spec for an unknown component without having to take guesses of whether or not supporting this behavior or not. So this means that we haven't been able to safely deploy new features because implementation simply don't know what's going on there. 5575 did try to work from the standpoint that the information is opaque, and in practice what has happened is pretty much no vendor implemented any sort of opaque behavior. Basically, if you couldn't parse it, the sessions were terminated. The problem that we end up having from this is we have a lot of people that are looking to do new pieces of FlowSpec work. Now, this is including L2VPN, MVO3, and there's, I think, on the order of 4 different extensions that are listed as being interested in extending FlowSpec that have not been adopted by ADR at this point. And the problem is we can't extend these things safely because of the new components are unknown. We've started the work initially 2016 for discussing what a FlowSpec v2 would be. Minimally, the FlowSpec v2 would be a more strict format for TLVs, which would allow us to actually work around this incremental deployment problem. But FlowSpec v2 potentially went into much deeper work, for example, taking the implicit rule ordering out of the system and enabling use cases where explicit rule ordering could happen. So that's a potentially large piece of work, and Sue, I think, will be discussing at some point how we carry that forward. But meanwhile, we're sort of stuck. And what I have for the working group is a proposal that, since with the current FlowSpec format, we can't deal with unknown component types, where a speaker can't actually announce a NLRI that the receiver couldn't parse. Well, the answer can be, the receiver uses some sort of capability to tell the sender what it's willing to deal with. And that's an important distinction from what's willing to deal with from what it is able to understand. We do also have use cases in the field where some device might want to speak FlowSpec, but not all components can be supported. As an example, Linux doesn't have in its IP tables a ability to deal with DSCP as a match criteria. Maybe it doesn't want to receive rules that it can't deal with. So in terms of how do you actually encode this type of behavior, the easy answer is a bit string. So what you're seeing in front of you is from the draft, simple bit string. Currently bits 1 through 14 are actually supported for 5575 as a base, and the v6 extension adds on one additional bit. Sorry, 1 through 13, and 14 comes from 5575 for v6. So in this case, we're just showing a bit vector that all the bits are being set. I will highlight here that this is in IETF bit list order, where the first bit is the leftmost one, the first one that's transmitted on the wire. This is the norm for things like SNMP. That said, other implementations are not fond of this format because they want to have it in machine order. The problem we're going to have here is that being up to 255 bits, it's never going to be something that will fit into a single machine word. So I suspect this will be the main contentious point for this proposal. That said, once you're willing to decide what the encoding looks like, the main operational issue that has to be discussed for any proposal like this, and we'll have this as part of V2 as well, is that what this effectively becomes is a filtering mechanism, where some FlowSpec routes do not get propagated because the speaker is not willing to accept them. And since missing FlowSpec routes based on the ordering considerations, if you have dependent rules, where one rule expects another rule to be present in the system, you can end up with unexpected filtering behaviors. And the consequence of that is that you may be addressing things, you may be setting them in the wrong orders, etc. So that said, this issue really does already exist versus any sort of filtering that you could do about FlowSpec today, and it's something that operators do need to be aware of. So this doesn't necessarily change the landscape, but it does highlight something that's a known issue. So in terms of what next, some flavor of this type of feature, being a very small bit of incremental work, could allow all these FlowSpec features to be able to be deployed. So the working group should consider, does it want to maybe adopt this draft or maybe spin something very similar? And clearly, we do need to continue the 8955 work in FlowSpec v2. And even in that case, some mechanism like this may actually be a necessary thing. I think we have time for a few brief questions. Donald, you're up.
Hi, just a real quick wanted to mention that actually the L2 VPN and NVO3 have a different SAFI, so there's no particular problem deploying them. Only when you're trying to extend within the same SAFI that you have a problem.
That is true. Haibo?
Can you hear me?
We can hear you.
We can hear you. Okay. I have two questions. That the first one is, what about for RR? If we do this, when the RR don't support some capability, so the routes will not send to R, then it will not reflect to other routers.
That is correct.
That is correct. Okay. The second question is that because at first the RFC 5575 defined the prefix with unknown component type will treat as an unknown prefix. So in that implementation, if I think it may not cause pass error, because if we find a component with we don't recognize, so we may treat the whole prefix as an unsupported prefix. So I think it may not cause some error. But I saw that the new RFC modify it and like to treat it as a malformed attributes.
That is correct. The discussion that the working group had for doing 8955 was that since we can't parse the NLRI safely, we can't tell if it's well-formed or not.
We can't tell if it's well-formed or not. Okay, that's all.
Okay, there being no further questions, we're up to the next presentation.
All right, can you hear me?
We can hear you.
Awesome, thanks, Jeff. All right, so I'm going to present the BGP FlowSpec payload match, which is basically a new FlowSpec component. So moving on to the next slide. All right, so what are the background and motivation? So today we have BGP FlowSpec, which is used for doing n-tuple filtering using layer 3 and layer 4 header fields, such as IP address or port number. And we have had recent advancement to IP routing forwarding plane, which is allowing to match at an arbitrary location a given pattern. So these particular capabilities can be particularly useful in DDoS mitigation, and especially a volumetric attack DDoS mitigation. So allowing to match a pattern in addition to the existing FlowSpec match criteria can be used for that. So moving on to the next slide. So this is an IPv4 packet structure, and this is just to illustrate what I was mentioning before. So this new FlowSpec component type will be allowing the operator to match a pattern within the IP header, layer 3 or layer 4 header, or within the data payload of the packet itself. So with this, like I mentioned, one of the main use cases is really DDoS attack mitigation, but it can also be used to match a pattern within a header field that within the IP or UDP or TCP header that would not be supported in FlowSpec today. That's a possible other use case. So the way we are defining this new match criteria within the draft is using a traditional encoding, so type length value, with a value which is basically made of two parts, which is the offset and the pattern itself. So the offset is going to allow us to say where in the packet, header or within the data we are trying to match, and then the pattern is going to be what is the value that we are trying to match on. So moving on to the next slide. Right, so we have the offset. The draft is defining two things, which for the offset type and then the offset value. So the offset type has at the moment 3 values, 0, 1, and 2. This is a convenience for the operator and for the DDoS controller that may want to program forwarding rules and filtering rules, which is offset 0 is the start of the IP header. Offset type 1 is the start of the data portion of the IP header, so meaning the layer 4. And offset type 2 is the beginning of the TCP or UDP data. And so this offset type is only meant to know where the offset value is going to be taken from. So taking an example, if you set an offset type 0, so the layer 3, the IP header, and an offset value of 0, then it defines the very beginning of the IP header. Another example, if you take the offset type 2, which is the data payload, so TCP UDP, and an offset having a connection issue.
We can hear you again.
Oh, okay, I could see reconnecting to the audio. Okay. All right, so another example is offset type 2 for payload TCP UDP and offset value 10. So we would define an offset which is 10 bytes after the beginning of the TCP or UDP data. All right, so this is only to define where we are going to match that particular pattern. So moving on to the next slide. Okay, so that's the pattern. So the pattern may come into a different form. The most common form for a traditional router will be the bit mask match, which is going to match a set of bits and with a mask. And then the pattern type, which is pattern type 0, and then pattern type 1 or 2 are for regular expression, and this would be more dedicated for software-based forwarding planes or appliances that would apply this type of filtering rule. So if you're looking at a bit mask match, the most traditional one, I would say, then you would have two things, which is the prefix and the mask. The prefix is the bit string that we are trying to match on, and we would end this with the mask value. So this allows to match bytes or bits within a particular prefix pattern. So moving on to the next slide. All right, so this is a practical example. So here you can see a UDP/NTP packet. And so assuming that the goal was to match on the NTP request code that you can find, that you can see in this packet, which is the value 42 here in decimal and 0x2a. So a possible flow spec NLRI would be to send a component type 4 for the IP protocol UDP, this is a UDP packet. And then this new flow spec component, which is a type TBD, and with the criteria that are mentioned here. So we would use an offset type 2, which is for TCP or UDP payload, an offset value of 3, which means 3 bytes after the beginning of the TCP/UDP data. So in this case, UDP. A pattern type 0 for a bit mask, and then matching on 0x2a as the value, and the mask in this case will be 0xFF. So this was to give a practical example. So moving on to the next slide. All right, so this was this is what I wanted to present about this new flow spec component and opening the discussion for comments and feedback. And depending on feedback, what I'm wondering is if there is options to pre-register new component types for early implementation.
Okay, I'm unable to track the queue at the moment. Sorry, the agenda time. So Sue, please let us know if we're still on schedule.
Schedule. He has about 3 to 4 minutes to discuss things.
Thank you. Haibo, you're first in the queue.
The first one is that I think this component type may be useful, but I'm a doubt that whether this component will make the chips more flexible, more complex, more complexable. And another question is that okay. Let me say first. Another question is that do we support multiple this new component composition? I mean that if we may use a method to match payload, but the payload cannot be described by one this new component. Can we use two? But if we use two this component types, I think now it may be cause some software to pass error.
So at the moment, so in the draft. Is it possible to turn off your mic? I have some echo. But yeah, thank you. Yeah, so the draft defines a single flexible match as a component per NLRI, but if the operator wanted to match different ones, then they can always send different NLRI message.
I had to remove Haibo from the mic queue for the echo. Robin, would you take your question next? Robin, you need to add yourself to the mic queue. Okay, we'll move along. Bill?
Sending audio.
Hi, Haibo covered a little of this, asking, will this increase the complexity of systems? I'm wondering what the benefit is of having two different regular expression systems. How will you choose which one to use in which context? And will implementations have to implement both?
So for the regular expression, this was a suggestion for software-based forwarding planes and appliances. So the driver there was that apparently those devices today uses either one of those two as their most common regular expression. But I would have to get back to you if you have further question on this. This will be
time for one question, and then we must cut the mic. So Sha, you won't be able to add.
Can you hear me, Filippo?
We can hear you, Robin.
Yeah,
okay. Okay. I think this is an interesting solution. It's like use the BGP to implement P4. But I wonder if we implement like this one to match some of this the payload. Have you taken into account the security issue. I mean so that if there's the mismatch, they may cause some this drop the packet with error.
Yeah, for sure. So in like a real deployment, you would typically have a DDoS controller and an analytic platform, and that analytic platform would be the one that would program the filtering rule, and that would be based on what it sees from the traffic from the network, right? So, but like in any filtering case, there could be cases of false positive, but the idea here is to reduce false positive compared to just doing layer 3 and layer 4.
Okay, I think this maybe thing may need more thinking. Okay, that's my suggestion.
Yeah, good stuff for the mailing list. So we're going to have to move on to the next presentation. Thank you, Philippe. So next up, I believe, is Yao Lu.
Can you hear me?
We can hear you.
Okay. I'm Yao Liu from DTE. My presentation is about BGP extension for SRMPRS entropy label position. Next slide, please. Entropy labels are used in the MPLS data plane to provide entropy for load balancing, and IFC 8662 proposes to use entropy labels for SRMPLS networks. As described in this IFC, determining the best place for EOI and EOPELs may not be an easy decision, and multiple criteria may be considered, such as ERLD and MSD of the node along the path, and limitations like segment type or maximizing number of LSRs that will load balance may also be considered, and an external controller can be used to program the label stack. Next slide, please. And this figure shows an inter-domain scenario. The end-to-end path from node A to node E is calculated by a centralized controller. Along this path, load balance is needed, for example, between BNC and CNX and DNE. And here gives an example of the label stack with entropy labels. And in this scenario, the ingress node is not aware of the EOID and MSD info of the nodes in domain 2, so node A cannot decide the position of the entropy labels. And the controller can be used to perform the computation of the entropy label position in the segment list of the path. And the candidate path with the entropy label position information can be learned by the handed node via different mechanisms, such as PCP or BGP. And so this document proposes extensions for BGP to indicate the entropy label position in the segment list when distribute SR policy candidate paths using BGP. Next slide, please. And this is the BGP extensions for SR policy. An E flag is introduced in the flag field of the segment subtier V to indicate the presence of ELI and EL label pairs, which are inserted after this segment. It is applicable to SR and PR segment types, and the ingress node receives an SR policy NLI with the segment list subtier V. The segment list subtier V contains multiple segment subtier Vs, for example, A, B, C, D, E, and the E flag of B and D are set. It indicates that if load balancing and entropy labels are required, then two ELI and EL pairs should be inserted into the label stack, right after the label for B and the label for E. And the value of the entropy labels is supplemented by the ingress node according to the load balance function of the appropriate keys extracted from a given packet. And whether to insert the EL pairs is decided by the ingress node. And next slide, please. I will welcome feedbacks and comments. That's all.
Hello. Hello.
Hello, Robin.
Hello. Yeah. My question is that one. I think that's because you mentioned that the SR. So I wonder why is necessary to indicate the position of the entropy label. In fact, several years we do this work. We can directly calculate the entropy label in the controller. So when download this the segment list for the SR policy, it can be directly to insert the entropy label to the seed list. So I think that will be easy to implement, and also because you know that the entropy label can be calculated correctly for the better load balance.
Oh, you mean that the controller is responsible to calculate both the position and the value of the entropy label, right?
Yeah. So I think that's need not to only to calculate the position. Yeah. I
see. And in this draft, we propose that the controller just calculates the position, and the ingress node keeps its function to inspect the flow, and the ingress node is responsible to calculate the value, and the ingress node just don't know where to put this entropy label. But I can, if you can send a draft, I can read it and compare and do some clarification more.
Okay.
Any further questions? Okay, thank you, Yao. We'll be moving to the next presentation. Xi, you have the microphone.
Yeah, hi, Jeff. Can you hear me?
We can hear you.
Okay. Hello, everyone. This is Jedong. I'm going to give a presentation about BGP LS extensions for the segment routing-based enhanced VPN on behalf of the co-authors. Okay, next slide, please. Okay, this is a little bit about the background. The enhanced VPN Plus framework is described in the enhanced VPN draft in TIS working group. It provides a layered architecture and the technologies to provide enhanced VPN or VPN Plus services. And network slicing can be seen as a use case of the VPN Plus service. And for the VPN Plus service, it is enabled by integrating the overlay VPNs and the underlay VTNs. As shown in this figure, multiple virtual underlay virtual transport networks and VTNs can be created based on a shared physical infrastructure, and each can be used as underlay for one or a group of VPN overlays. And together, the VPN overlay and the VTN can build the VPN Plus service to the customers. In the Spring draft SR4 enhanced VPN, it described the mechanism and procedures to build the SR-based VPN using the resource-aware segments. And for the IGP extensions to distribute the SR VPN information, there are several drafts under discussion in the SR working group. And both multi-topology or flux algo can be reused or combined with necessary extensions for this purpose. For this draft, it defines a corresponding BGP LS extensions so as this SRVT information can be distributed to a network controller. Okay, next slide, please. Okay, this is the design principle of this draft. As shown in this figure, a VTN may cover one or multiple areas or domains, and also the interdomain links. And in each area or domain, we can use multi-topology or flux algo to advertise the topology attributes of the each VTN. In different domains, they can use the same or different topology or algorithm IDs for the same VTN. And within each domain, multiple VTNs can share the same topology or algorithm, so that we can provide a more scalable mechanism to support a large number of VTNs. Then for each link, including the intra-domain link and the interdomain link, L2 bundle can be used to advertise the link T attributes associated with each VTN. Okay, next slide. Here are the extensions to BGP-RS. Basically, there are three new TLVs defined. The first one is called VTN definition TLV. It is used to specify the association between the topology ID, algorithm ID, and the VTN. So that multiple VTNs could refer to the same topology or algorithm ID, so that they can share the topology advertisement and can share the topology computation. This TLV can also be extended for further attributes. The second TLV is called VTN ID TLV. It is used to identify a set of VTNs an intra-domain or interdomain link belongs to. Then the third one is called link attribute flux TLV. This one is correspond to the ISI's link attribute sub TLV, and in this
Jeet, we have lost microphone for you.
Are the other co-authors able to continue on with the slides?
Can you hear me?
We can hear you again.
Okay. Yeah, I got lost for a moment. So I think I finished the VTN ID TLV, right?
Right.
Okay. For the third one is called link attribute flux TLV. It is used to advertise the link attributes for a particular link, intra-domain link or interdomain link. We introduce a new flag. V is to indicate whether the link is a virtual link or a physical link. Okay, next page. Okay, for the intra-domain topology advertisement, we have two options. The first one is based on the BGP-RS with multi-topology, so that we can use the MTID TLV in the BGP-RS analyze to identify the link state information of different topologies. We can also advertise the topology-specific SRMPRCs in the BGP-RS attribute. For the SRv6, also the topology-specific SRv6 locators and seeds can be advertised based on the BGP-RS SRv6 extensions. The second option is we can use BGP-RS with flux algo. We use BGP-RS flux algo definition to describe the topological constraints on a particular topology, and the algorithm-specific seeds can be carried in the BGP-RS attributes. For SRv6 is similar. The SRv6 locators and seeds can also be algorithm-specific. These are just two options. They can be used in one or multiple areas or domains, which build the interdomain VTN. And with either option, the topology information, the topology-specific computation could be shared by multiple VTNs. This is how we can improve the scalability. Okay, next slide. This is about the interdomain topology advertisement. Basically, it is based on the BGPRS EPE with a new VTN ID TLV to specify the VTN specific interdomain connectivity. And based on the granularity of the information you need to describe for the multi-domain VTN, there are 3 different VTN specific BGP peer seeds, like a BGP peer adjacent seeds, BGP peer node seed, BGP peer set seeds, can be advertised with the VTN identifier TLV to specify the interdomain link for a specific VTN. Okay, next page. For the VTN specific T attributes or resource attributes advertisement, it is based on the BGP LS L2 bundle mechanism. And we can extend the L2 bundle to either a physical bundle or a set of virtual member links on one physical link, so that each virtual member link can have a separate set of T attributes. This is indicated by using the V flag. And for each L2 bundle member link, VTN ID TLV is used to identify the associated VTNs. And then the T attributes of the L2 bundle member link will be used as the link attributes in the constrained path computation of the associated VTN. Okay, next slide. Something more is we need some identifiers of this VTN in the data plane. It is used to steer the packets to the set of resources allocated to a VTN. With different data planes, we have different TLVs. For SIMPRS, we have the TLVs for VTN-specific prefixes and adjacencies. For SIV6, we introduce a new TLV for the VTN-specific SIV6 locators. The third option is we may also have a dedicated VTN ID in the data plane so that we can save the overhead of introducing new TLV for carrying this VTN specific data plane identifier. Well, this requires some extensions to the data plane encapsulation, and there are several options under discussion in other working groups. Okay, next slide. Okay, for this document, we know that the BGPRS extensions may need to align with the IGP extensions. So, for at this current stage, we just like to solicit feedbacks and comments on this document so that we can refine it accordingly and to move along with the IGP extensions. Thank you.
Do we have any questions? Robin, do you have the queue?
Hello.
Hi.
Hi, Robin again. In fact, for this draft, we would like to add one point. In fact, when for the network slicing work, the most important design is the scalability. We think that here this is introduce the BGP link state extension to report this network slice information from the device to the controller. But on the other hand, because we know that in the network side, we also need the IGP to advertise the network slice information. But this for the IGP flooding, there's still has challenges. So we propose the draft that is the BGP SPF extension to advertise the network slice information. Here, I just remind you about this draft, which also related with BGP, and also the extension is similar as the extension of the BGP link state. So it's also to enhance the scalability of the network slicing solution. Okay, that's my point to be added.
Any further questions? Okay, in that case, we will proceed to the next presentation.
For bringing us 5 minutes back.
Next presenter is Kaliraj.
Hi, Jeff.
Hi, we can hear you.
Okay, good. Hi, everyone. I'm going to present BGP Class 4 transport planes again. So last presentation was in IETF 108, and this is the next presentation. Next slide, please. So basically, the agenda is it's a short agenda. So I'm going to recap the BGP-CT problem statement, solution, advantages, and share some changes to the draft and some tidbits, learnings from the implementation qualification so far, and introduce the later drafts and next steps. Next slide, please. So yeah, the problem is simple. So in any network domain, we may have intra-AS tunnels with varying T characteristics. So these are like tunnels from different transport protocols, and they can be tunnels to between the multiple tunnels between the same set of destinations. And they would have different T characteristics, and service routes may want to put traffic on them based on their needs. And these tunnels may need to be extended inter-domain while preserving the same T characteristics end-to-end, and such a way that the service routes are able to map traffic onto them without worrying about whether it is an intra-AS tunnel or an inter-AS tunnel. The mechanism works the same way. And service routes may also want to have an option to fall back to tunnels of a different T characteristic, including best effort tunnels. So the problem was how to extend BGP to signal this piece of information and get the job done. And it's best if the solution is agnostic of protocols or components in the transport layer or component in the service layer, so that it works with any set of these protocol components in each layer. Next slide, please. So the solution constructs in BGP-CT. Basically, we just talked about the different tunnels of different T characteristics. So we just have a transport class construct which collects tunnels of the similar characteristics. So it doesn't think about what type of tunnel it is or which endpoint it is going to. It's just a transport class, which is a type of tunnel. So operators can classify the tunnels in their network to say these are like my gold tunnel, these are silver tunnels, and they have an identifier. The transport class also has a 32-bit color. That's an identifier. And we use a BGP-CT. There's a new BGP address family which plays at the transport layer. So when I say it's transport layer, it just means that it carries prefixes which are used as protocol next stops in BGP updates. And this is a SAFI 76. It's called class 4 transport. And it follows RFC 4364 procedures, which is basically BGP MPLS VPNs. So this, what it does is it just collects the tunnel endpoints, the ingress routes that we have in the network, and disseminates across BGP speakers to other domains and collects them in transport ribs for that transport class. And so that service routes, when they want to resolve over a certain transport class, let's say gold, so they will just confine their next stop selection from the routes that are collected in the transport rib. So it's as simple as that. And the ingress routes collected in a transport class are advertised in BGP-CT family to other speakers with the very familiar encoding, like we use RD : tunnel endpoint as the NLRI, and the transport class route target that identifies the TCA it belongs to. So this is just like a L3 VPN update, where we are just using RD to as a distinguisher, and we are using a new type of route target. And this is just so that we don't have any collision with the service plane route targets. And so BGP-CT extends these tunnels across the domain boundaries by doing the resolution confined to the transport class, just like I explained. And it follows the option C style procedures when the route BGP-CT route is advertised across a BGP speaker with next stop self. It just creates a swap route which basically connects the two gold LSPs in the two different domains. And those LSPs could be belonging to different transport protocols. And so it should be said that this also works in conjunction with option A and option B scenarios. And it also works with scenarios where you have a single domain and it has an ABR in the middle. So it's like two regions. And the service routes, the way they resolve over these is using a concept called a resolution scheme. So the resolution scheme is nothing but it says you resolve over a certain transport class with an option to fall back to a best effort or another transport class. And these resolution schemes are like local constructs on a receiving box. And the way the egress router or a BGP route that is received on an ingress router communicates its resolution scheme. Intended resolution scheme is using a mapping community on the BGP route. So this mapping community can be any community for that matter. For example, the color extended community that is already widely in use to map services. So they can be used on the service route to say that please map over the color N tunnels with a fallback on best effort tunnels. That's the default mode. And BGP-CT routes, because they want to confine to only tunnels on that transport class without having any fallback, the transport route target is used as a mapping community on those routes, and it resolves strictly over the color N tunnels. And if users want different resolution schemes, saying I want a primary path through gold versus a backup path through silver, so those can be separate resolution schemes that can be configured on the box. Next slide, please. So this is just a recap to show how similar the update looks like, just like L3 VPN. So we just have the route target, transport class route target, and instead of 128, it is just 176, and it will be 276 for V6. And we have the article of the endpoint. Next slide, please. So this picture just recaps whatever we just talked about. So it just shows an example, two ASs. The left side AS2 is split into two domains. And we have the border nodes in these ASs, which are like ABR and the ASBRs. So the BGP-CT routes, they can be either originated at PE11 or they can be originated at ASBR11. At ASBR11, they will be redistributing the RSVP or SRTE or FlexLGO routes into BGP-CT, and they will create the swap routes at ASBR11, and they will get further redistributed by ASBR23 across to ABR22, across to PE21. And at each of these border nodes where it is doing the stop self, it will just emit the MPLS forwarding entries, which connects these LSPs of the same color. And at PE21, we can just map the service routes that are coming with the mapping community of gold or bronze to say that I want to map the service traffic to the gold. So end to end, we get the service traffic taking the gold LSP. And needless to say, ASBR11 could also have service routes received, which can resolve over the same gold LSP in the same way. Next slide, please. So I wanted to take a moment to recap the advantages of using 4364 encoding. So we use the route distinguisher to allow the multiple distinguishing between the multiple tunnels to the same destination. So it avoids using multiple loopbacks to the egress P primarily, and it avoids path hiding when transiting through the RRs or redundant ASBRs. Allows unambiguously identifying the originating PE. It's good for debugging. And it also supports tunnel endpoint being an anycast address participating in multiple domains, for example. And it allows path selection for the tunnel endpoint after stripping the RD when necessary. So this is helpful for faster convergence. So basically, RD is an identifier of convenience. We can use it when needed to go through RRs and avoid path hiding, and we can strip it when it is not needed. So, and it is preserved end to end. So there's no ambiguity there. And using the 4364 style route target to propagate transport class. So that allows forming Venn diagrams of color domains as desired. It's basically directly maps to the L3 VPN like VPNs that we have. And we can support different models where you have core networks having more fine-grained colors, and the access networks may not have that many colors. So those can also be represented in this model just by using multiple route targets on a route. or a different kind of the core domains having a different route target import and the access domains having a different route target import. And other creative use cases can be possible, as we have seen with L3 VPN in general. And treating color as an attribute, that's an adjective rather than part of the NLRI, it helps in cases where domains have different numbering of color values. Attribute rewrites is easier than rewriting NLRI. And there is no ambiguity of where is my color. It's always as an attribute as part of the route target. And because of reusing 4364, we can also reuse route target constraint procedures to do on-demand next hop. And there can be a clean API between the service routes L3 VPN and the transport layer BGP-CT, because using service routes we could just determine what transport class routes we want, and the access nodes can just request an RTF for those transport class routes, enabling them to receive only the BGP-CT route that they need. And it basically reuses the time-tested, well-deployed VPN machinery, and that cut down implementation time, testing time, and improves reliability. And I would also, I'm a big fan of RFC 1925, and one of the points that I like that is in protocol design, perfection has been reached, not when there is nothing left to add, but when there's nothing left to take away. And we felt that because 4364 perfectly solves the problem, there's nothing required to be added really. So we just reuse the same thing in a different layer. Next slide, please. So these are the updates since IETF 108. So we just added some illustration with topology, which helps understand the procedures described before in the previous sections. Added MPLS OM section, and documented case of redundant ABRs doing next hop self. Basically, RRs with next hop self, whenever there is they do forwarding, this problem can happen. And I found surprising that it's not recorded anywhere. We just took the opportunity to record it in this draft. We will look at it in detail in the next two slides. And we added scaling consideration section. We recommend RFC 8212 as a default behavior for city family, which basically says don't export anything to BGP peers without having an explicit export policy. And route target filtering can be used for BGP-CT to provide ODN and MPLS namespaces. This is a new concept that can be applied not only to CT but also to BGP-LU networks to deal with scaling in seamless MPLS networks. So there may be a presentation for this topic in best working group if time permits. And we also added the applicability network slicing section because it was brought to us notice that the transport class part of this solution, it fits nicely to the, it represents a topology slice part of transport slice. So a transport slice and network slice is a topology slice added with some resources to it. So the transport class neatly provides a topology slice that the service routes can bind to. And since IETF 108, we have also had good discussions on the mailing list, and we are very pleased to welcome co-authors from Verizon, Cox, Alibaba, Google. Thank you for your support, and we have working code. Next slide, please.
And quick time check, less than 2 minutes.
Okay, so this is just, case of redundant ABRs in a BGP network where they're doing next hop self, and they can be loop that's formed in between them. Can you go to the next slide, please? I'll just explain using the topology. So here we have redundant ABRs, which are basically RRs with next hop self. And if you look at this picture, ABR23 will be receiving the routes with ABR22 as the next hop, as well as the ASBRs as the next hop. And it may so happen that because of IGP metric, ABR23 may choose ABR22 as the best path, and ABR22 may do the same. And there's another gotcha with the RR RFC, where it considers cluster list path selection after router ID. And that is also another thing, because based on the router ID, they may select each other. So network planners have to carefully select the IGP metrics to make sure that the ABR select the ASBR instead of the peer ABRs. But with CT, we have a even better alternative deployment-wise. If you don't provision the color tunnels between ABRs, they will never select each other as the next hop. So that avoids a traffic loop. That's just what I wanted to point it out. Next slide, please. Okay, so these are just the related drafts. So the first draft is extending PSEP to carry color for RSVP tunnels. So I think we already have a PSEP draft for SRT tunnels, but this is what this is doing for RSVP. So that it just completes the solution. And seamless SR use cases, this is a draft that's already existing. You may be familiar with it. It just explains the various use cases possible using BGP-CT. And there is this draft that we are working on to provide interop between SRv6 and MPLS. And the MPLS namespaces draft we just talked about. And the generic RTC is an extension to route target filtering to make it work with wider route targets. So it just the other drafts that are there to complete the whole solution. And I think that's the end of my presentation. And on behalf of co-authors, we feel that we are at a stage where we can request for work group adoption of this draft. So we will make that request formally to the chairs to consider it. I think I can take some questions.
Actually, we are out of time slot. Sue, what time do we have available?
In addition, Arjun, you will need to be ready to present next. We are lacking the DJ for the presentation, and so they're finding one of the co-authors. So a few minutes would be good to give Arjun ready to present next. Go ahead with the discussion.
Okay, first in queue is Zafar.
Okay, so that's the draft that Sue just mentioned. There are a couple of drafts next in the presentation that is in the same area. So I think it's premature to adopt any work.
Okay, if Zafar has nothing further, Stefan's next in queue.
Yeah, Stefan Litkowski speaking as. Do you hear me? Does it work?
I hear you.
Oh, okay, good. Yeah, Stefan Litkowski speaking as BES co-chair. I think before adopting the document, we should also clarify to which working group this document belongs, because there are a lot of things that are related to VPN semantics and so on, and this is more something which is related to BES. So we should also have a discussion on between the chairs on where this is, what is a good home for this work, whatever it's this classful transport document, but there are also other documents that are related to the same topic.
Okay, Stefan, if you have nothing further, Haibo, you're next in queue.
Hello.
Hello.
Okay. I have a question that I think this chapter defined a new SAFI. This SAFI use RD plus prefix and also as the key, and also use a transport class extend community. So this method include import two new value. One is the RD, and the other is the transport class. So I think it may cause the user to plan the network more flexible. So is it suitable to use a new value, or otherwise perhaps we may use only one value is enough?
So the SAFI is a new, to make it a new AFI SAFI so that it doesn't collide with any other service families. So that's separate from the route target, new type of route target. That's a new format of route target, in fact. New format of extended community, that's transport class. So they are two different things. Did I get your question right?
Haibo has taken himself out of the queue. Srihari, you're next. Sorry, actually, Shahari, apologies. Sue says that we have to cut the line now.
Okay.
Okay, thank you.
So obviously interesting stuff. Go ahead, Sue.
We need to have Arjun go next. On his presentation, the car presenter is running into trouble. So Arjun, could you go next, please? This is Jeff. You'll need to go forward.
Okay.
Thank you.
Sure. Hi, this is Gian with Verizon, and I will be presenting the analysis of VPN routes controlled in a shared BGP session. So this is for the RDRF solution, I guess on the mailing list, as was discussed, to present and review the analysis of filtering the VPN routes and coming to a consensus before we move on to the solution. Next slide. So the motivation of this draft describes a scenario where we need to control VPN routes on a shared session, BGP session between the PE and RR, where a flood of routes get advertised between the from a source PE to a downstream receiver PE. The goal is to reach consensus on the problem analysis and solution requirements, and then establish base for the to forward into the updated solution. Next slide. So we'll start with the simplest scenario. So this is intra-AS. So in the intra-AS scenario, we have a case one where we have an RD allocated per VPN /PE, so a unique RD per PE, and only one RT is associated with such VPN routes. So in this case, the PE3 sends an excess routes for VPN with a route target of 1. So the VPN, the PE3 source PE with VPN 1, RD3 is the offending one that's sending the flood of routes for RT1. And here we only have one. We have a PE1 in the top left-hand corner that's importing that RT1, and it's being impacted by the flood of routes. The second use case is a scenario where you have you have the unique RD per PE, but again you have multiple RTs that are associated with the VPN. So this is critical to take into account where you have because there are multiple RTs that are being that are associated with a VPN. In this case, it's RT1 and RT2. Both RT1 and RT2 are imported on PE1. But VPN1 is the one that's receiving the flood of the routes, where VPN2 has RT2, but it's not. It's also imported into VPN2, but it's not being flooded. So that is something to take into account in the solution for the intra-AS, as well as this comes into play as well in the inter-AS scenario. So next slide. In the inter-AS scenario, the same situation exists where you have a single RT for a particular VPN or multiple RTs imported for a particular VPN. So for the inter-AS scenario options B, A, B, and C, we have a BGP session that's shared. So between the ASBR1 and ASBR2, the VPN IPv4, IPv6 session between the ASBRs. And then between the PE and ASBR, you have a session. So the possibility exists that you could have an excess of VPN routes advertised the same way that we have within the intra-AS scenario. So the overwhelm of routes, so the flood of routes coming from the source PE from the AS on the right, PE3. Here we have VPN1, RD31 is sourcing the flood of routes, and that VPN. If it is being imported by PE1, the receiver PE, which is being impacted. So in this scenario, having a way to control the VPN routes that are originating from the source RD31 that's flooding VPN1. In this scenario as well, there's also the scenario where you have multiple RTs that are associated that are being imported on the source PE, but to take into account that only to filter the routes between the ASBR and PE1 only if all the VPNs are being impacted on that PE1. Next slide. So VPN routes in this scenario we have VPN routes that are being we have the common P to R session that's shared VPN4, IPv4, IPv6 routes that are being advertised down to the PE, and we have a source PE that's advertising a flood of routes. So the PE1 that's being impacted by the flood of routes from a source P that's advertising for a particular source RD, we need the PE should have the capability of controlling that distribution of VPN routes with some type of mechanism. But the key here is only when the VPN that has a flood is associated with that's impacted, that all VPNs that are associated with that RT are impacted, and that is the only time where the routes would be filtered between the PE and the RR. If there's if there's more than one VPN that exists that are importing the same route target, multiple, in the case where there's multiple RTs associated with the VPN, that is something we would take into account, and that's where we would not filter the routes between the PE and the RR. Next slide. So potential solutions would have to meet the following requirements. So the control messages on the for the specific VPN routes would be triggered automatically upon the hitting an excess VPN route limit. So the maximum prefix limit on the VPN hitting a certain threshold, and with that trigger, there's certain criteria for the control message to be sent out to block the source PE that's flooding for a particular RD. So at the PE layer, when all the VRFs on it don't want to process it, the control message would be sent out at the PE layer. At the RR layer upstream, when all of its BGP clients don't want to process the flood of routes, then the control message would be sent upstream to block the flood of routes. And then at the ASBR layer as well, when all of its downstream peers within that AS don't want to process the routes, then it would be sent inter AS to the other adjacent ASBR. And then lastly, if all of the above, don't want to process the VPN routes, that the control message would be sent upstream. So this would be an automatic control message that would be sent out based on the trigger that happens, based on a maximum prefix or other type trigger that would send a control message. So step B, with a step C manual removal of the control message, just to prevent any possible instability of flapping that could possibly occur. Next slide. So we'd like to get comments on questions and comments related to the problem statement, and then the goal is to have a clear definition of the problem and be able to move on to the solutions and requirements for the solution, and start on updating the solutions draft. Next slide. Sorry.
This is Sue. I'd like to make sure we allow plenty of time for feedback on the problem statement. So if you're going to go into solutions, if you'd hold and make sure you get comments from the working group.
Sure, sure.
Thank you.
Thank you, Sue. That sounds good. So if anyone has any comments, please, we can run through any questions on the problem statement.
Okay, if we have nothing in the queue, perhaps we can proceed.
Okay. All right, thank you. So potential and proposed solutions. So once we receive the consensus, and we'll take this to the mailing list as well, just to make sure everyone is in consensus on the problem statement, and then we'll move forward and go on to the solution. So now we'll proceed to the next slide. So next slide. All right. So as far as the solution, starting with the simplest intra-AS scenario. So in this case, number one, so in this scenario, we have a source PE3 with VPN1. So there's a single route target that's has that's sourcing the flood of routes related to our RD31, and we have a receiver PE1 that's receiving the flood of routes, so our RD11 that's being impacted. So here in this first case, once PE1 detects VPN1, the VR has overflown. He has a few checks that he goes through. He will check to see if the VPN routes that he has are RD31 that are causing the excess routes coming from RT1 that are being imported, and then RD checks for the RD31 source of the flood of routes. And then he ensures that no other VRs are importing the VPN routes for RT1 before the mechanism for the trigger can happen. So once he's done that, once he's determined that there's no other VRFs that are importing RT1, he'll trigger an RDRF message back towards the RR. So the RD field is set to RD3.
We have lost audio from you. Ajin?
So can I continue?
Can you hear me? Can you hear me now? Sorry.
We can hear you again.
Sorry about that. Okay. So let me just back up a little bit. So PE1 triggers an RDRF message to R1 with the RD field set to RD31. R1 withdraws and stops advertising the message, advertising the excess VPN routes to PE1. So once VPN service on the PE1 will continue operate. So all the other route targets are not impacted. It's just the RT1, and it's really in the RD31 where the RDRF is being filtered in the use case number one. So the only impact is really resolving the problem with the VPN1 that's importing the RD31 is the one that's filtered. VPN2 continues to receive the import of RT2. In the case on the right, so use case number 2, on PE1 we detect VPN1, the VRF is overflown. So this is for VPN1, RD31. RT1 is a source PE on PE3, so PE3 that's has RT1 sourcing the flood of routes. And in this case, PE1, he has the import of VPN1 importing RT1. But in this case, there's two RTs, or there's RT1 and RT2 are being imported by two different VRFs, VPN1 and VPN2. VPN1 is impacted, but VPN2 is not. So in this case, the PE1, because of all VPNs, there's multiple VPNs that are importing the RT. PE1 would not send out an RDRF back towards our R1. So this is a careful consideration, and it's local configuration as part of the specification that we would only send the RDRF for all the VPNs that are attached to the PE are importing the route target that are being flooded. So in this case, because there's multiple RTs are imported by multiple VPNs, but the other VPNs are not impacted, we would not send the RDRF up to the RR. Next slide.
So time check, you've exhausted your 15 minutes. Could you try to wrap up?
Sure. Thank you. Okay. So this is the NRAS scenario. So in this scenario, we have the same consideration that happens if the access VPN routes for VPN 1 or 2. So in this case, we have VPN 1. RD31 is the source RD that's being advertised, that's being flooded over from the AS on the right to the AS on the left. It's being imported by PE1. So here in this case, if there are no other VPN to import the RT, then the XF VPN routes CAT. So PE1 will trigger an RDRF with the field set to RD31 or RD32, and it'll send it up to the ASBR. So as long as there's no other VPNs that are importing that RT1 that's the impacted one. So when the ASBR1 receives such an RDRF message, it'll check if all its downstream peers have sent the same message, and to process the VPN routes with the access capability, it'll send the message upstream to ASBR2. So it'll do the check and make sure all the downstream peers have sent an RDRF, and then it would send the RDRF upstream. So P1 and P2 receives the RDRF from both set with the field set to RD3, and then the ASBR1 will send the RDRF upstream. Yes.
I'm really sorry. We have to stop the presentation at this time in order to give the next presenter a potential. Could you just wrap up your slide, please?
Yes, sure. So I think at this point, we could take questions if anyone has any questions or comments, and then we can take it to the mailing list. Any questions or comments on the problem statement or the solution?
I think we're going to have to defer those to mailing list or to chat.
Okay. All right. Thank you.
Thanks for the presentation. I am in the process of locating the next presentation for our co-authors. Please add yourself to the speaking queue.
And it should be Swadesh. Swadesh, are you ready to present instead of DJ?
Yeah, hi. Yeah, I will present. Yes.
We can hear you. Please go ahead.
Yeah, hi. So this is about BGP color-aware routing problem statement, and these are the authors and the co-authors that we are working for this problem statement document. Can go to the next slide. So BGP color-aware routing is about providing an end-to-end intent-aware path in the multi-domain service provider network. And by intent, what we mean is like low latency, or to avoid certain link, or even avoiding certain domains. That's what we want to create an end-to-end intent-aware paths. Next slide. So there's a reminder for deployed solution. We know today there's a SRT-based solution in which is defined in the Spring already with the IETF Spring segment routing policy document. It's mature, widely deployed, and it has multiple implementations. And it has a notion of color to represent the intent. And in our BGP car solution, we will just extend that notion of color to represent the intent mentioned in the initial slide. Next slide. So the way it works today is existing solution would be, as we are showing in this picture, we have a E3, which is advertising the VPN prefixes through service RR to E1, and E1 and E3 are your PEs. And now what is important is a VPN service, that means in this V/V is requesting a colored service. It wants to go over an intent aware path. So the VPN service is colored with the color blue, and it is done today through a BGP color extended community to say I want to use the color aware path. Next slide. So what happens is today we have a automated steering for this purpose. So when E1 receives that colored VPN service from E3, E1 requests SRPC to compute the interdomain path, since E1 is not aware of how to reach E3 in the multi-domain network. SRPC sends the SR policy back to E1 that suffice that intent. That could be a low latency path or avoid certain links. So this E3, C, that means to reach E3, a transport with a certain intent is an intent based path towards E3, and that is already provided today by SRTE mechanisms. Next slide. So automated steering evolution. Now we want to provide same facility, whatever we have done in the state of art today via SRPC. Now we want to do through BGP. So what we want to do is we want to advertise the reachability to E3 with a certain intent, and that intent provides the using the inter-domain intents like flex algo SR policy. So we want to advertise the E3 reachability via hop through these inter-domain routers, and that's what it shows. This example is so the focus of problem statement draft is we wanted a clarity on the deployment requirements. We want the solution should be compatible with the existing SR policy. It should coexist with the SR policy, and the BGP color-aware routing should coexist. There should be interworking of between these two solutions, because this is a well-deployed solutions to provide intent-aware path in multi-domain network. And we want to keep the concept of color. It's a built-in color which provides the automated steering today. And the scope is not just about transport. The scope is about also intent-aware VPN layer, because we know a CE may also want to go through a transport network which provides that intent, not just a PE. And so we want to integrate with the NFV. So this solution, like SRT solution, already integrates with the NFV. We can put the segments of NFV. This solution should try to provide that intent-aware paths also. So the clarity on the scale, requirement, and constraint. What we are talking about here is now advertising the transport addresses, the PE loopbacks with the intent. So today we just advertise the best effort. If you're trying to advertise the intent with BGP, our scale will increase. Today there are networks with 300 KPEs, and if you have even 5 intents, we're talking about 1.5 million prefixes. So it's more than the label space that is available. And also we have to think about the BGP control plane filtering for transport, for the convergence, and for other reasons, as I mentioned in this. And the problem statement document clearly lists all these things, and it lists the intent use cases, as well as it lists these protocol requirements. Next slide. So we have, for this problem statement, we have been collaborating with lead operators, the vendors on the analysis, and we would like to acknowledge the contribution to this draft by many such operators and the vendors. And we recognize the prior work in this area, which is seamless SR and the class full transport that's already presented. We have an ongoing collaboration with the seamless SR co-authors for the consensus for the problem statement. We have reached out to them in November and December. We recognize the prior publication or use cases. We published the problem statement with the analytical approach, as I mentioned, or the reasons behind it, the state of art, the notion of color, which is central to provide the intent, and looking at the analytical analysis of all the intents. That's what the document is all about. And we have a joint discussion going on with the co-authors right now, and we are looking for eventual partnership with the new set of documents in this area. Next slide. Next step would be we're requesting the review by the working group of this problem statement document.
Questions
Swadesh?
from your first presentation, Swadesh, or is that the pause, or are you having connectivity problems?
No, I am fine. So I will move to the next slide, which is about BGP, actual BGP solution. The first one was a problem statement. So this is a BGP color-aware routing solution document we have published. So this lists the co-authors. Can you go to the next slide? Yeah, so since we just discussed in the problem statement, we have to advertise the reachability with the multiple intents now. To reach a certain PE or the endpoint, we need to advertise the same prefix with the different intents. So we need a ability. So that means we need a new SAFI in which we need ability to signal the multiple instances of the same prefixes for each of the colors, for each of the intents. That's the requirement. And the solution draft discusses the following aspect: the desired data model, because we know it's a new SAFI and we have to advertise the multiple instance of a prefix. And what we support is the multiple encapsulations. We have to support MPLS, SRv6, IP, different types of encapsulation, their signaling as well as validation. So we should also validate that the encapsulation is programmed in the hardware. We have to also go into the aspect of route resolution, how to resolve these BGP car routes over the intra-domain tunnels, which can, and the intent can be provided by the SR policy or through the IGPFA, or through even it can be also supported by RSVPT or SR MPLS or LDP for the fallback cases. And also the steering mechanism, as we discussed, the notion of color is central for the steering of the VPN services into these BGP color-aware routes. Also, it has to be, we provide the scale characterization, because we know for best effort, we advertise only a single BG prefix, but now with the intent, we are multiplying that number. It's number of P's into number of intents you provide in a network. So the scale characterization is very important to see this transport network can scale to the requirement. And that brings the next aspects, route filtering. Route filtering is to make sure, I will go in that, just to we filter what you are interested in. The next slide. So data model is, we have to advertise the PE IPv4 loopback or IPv6 loopback. So it's in the global space. That's the prefix in the data model. Color, as we discussed, distinguishes different instances of the prefix, and also it indicates the service or a intent associated with the route. Whether it's a low latency prefix, or it's providing avoiding certain links or avoiding certain domains. So that's the intent that color provides. The next hop, BGP next hop, is as usual. It provides the reachability verification in the control plane. The encapsulation, we have to support different technologies, that is existing MPLS, SRv6A, or the IP. We should also support the multiple encapsulations, and reason is for migrations and coexisting cases in the same network. AIGP, again, AIGP would be, as we know, it accumulates the IGP as the BGP prefix advertised. It's the same. In this case, we will try to accumulate the intent specific metric as the BGP route is advertised, hop by hop. Next slide, please. So the proposal for the car is, the NLRI key is E. E is a endpoint, the PE loopback address, most likely in this case. So it's an IPv4 and IP6 endpoint prefix. And we have to understand this is network-wide unique. So E provides that uniqueness, and color is the ways to advertise it, and also the intent, as we discussed. So color is consistent across the devices within a color domain. So that means the color mapping within a domain is consistent. All the devices understand a specific color for a specific intent. Color is also same conceptually from the BGP color extended community that is used for steering purposes. When attached to the VPN routes, it tells to use this BGP color aware route. And next is the prefix is unique. E is unique in the inter-domain transport network. Example P makes E, C unique even if C is local to a color domain. So that means if the color mapping changes, and if we advertise this NLRI to a different color, to a different domain where there's a color mapping is not consistent, then also E, C makes it the NLRI unique. Next slide, please. So there's also a local color mapping extended community introduced in the draft. It's optional. It's used only if we go across the color domain boundary. So if there's not a consistent mapping of the color, we will attach this extended community, and that would be mapped locally in the domain to the domain understanding of that color. So the NLRI is not rewritten at such inconsistent mapping of the colors. It's preserved end to end. Next slide, please. So encapsulation, it's very important that since it's a new SAFI we are adding, we have to make sure we don't take the baggage of the past. So we don't want the to be our new SAFI be constrained by the 24-bit MPLS that we have in today in our different types whenever we encap the label. So it's an opportunity to have a more cleaner design. Also, we have to make sure the NLRI carries the variable part of the encapsulation for the packing efficiencies. And that's what is already in our proposal. And also to validate the data plane for the encapsulation availability before we make a BGP best partition, we also make sure that since we will like to support multiple encapsulation, you have to make sure those encapsulations are programmed in the forwarding before you make those decisions. Next slide. So scale considerations, as discussed, we are talking about BGP transport, and that transport is now advertising the intent also, which can it could be 4 to 5 intents or more than that in a network. So we have to make sure that our current MPLS limitation of 1 million labels, we can still make the things work. And for that, we need a hierarchical design. And this, what will make sure is our core routers, that means something which is in our super core or core, doesn't learn all the PE addresses. They only learn the addresses of the border routers. But that brings the recursion as well as the data link complexity at the PEs and BR. So those are discussed in the document. And the most important aspect is the filtering because of the scale. As the PEs learn the service route, we should make sure that PE only get the intent of a BGP car routes for which it is interested. It only learns the endpoints and its intents for which the service are talking to each other. So that brings the filtering mechanism that is introduced in this document, that we make sure we only learn the PEs for which the PE or even ingress BR border router has an interest, so that ingress BR also doesn't have to scale to the label scale required. It only learns what is the piece which is behind that ingress BR is interested in. Next slide. So next, so we want a working group to review this document. Thank you.
It's over time. Thank you for your time. The authors may take questions, but pretty much within 2 or 3 minutes, it's going to be cut off. So maybe, Jeff, shall we cut the queue and not run into the end of the hour?
So my suggestion is the official meeting's over at top of hour. We have basically a few minutes until the Meet Echo service simply terminates the session without warning. So if somebody wants to be brave enough to ask a question and the chance of being cut off, I would say go for it.
Please go ahead. Okay. I think Linda's in the queue.
I have a question about different instance of a. I thought we already have route distinguisher to distinguish different prefix. So what does that different instance mean here in your slides?
So today in the transport network, there is no route distinguisher. This is something, it's a new SAFI we are introducing. So we are still a distinguisher we are thinking would be a color. As we know, the notion of the color is to carry the intent from the past by SRT mechanisms. So we want to use the same notion of color to advertise the different ways to reach a particular prefix. In this case, a particular PE or a loop back of it, E. So color is the one we want to use as a distinguisher. And E is the one which makes it globally unique instead of route distinguisher.
Well, you're saying the colors to represent different ways to reach the same destination, right? Same prefix.
Yes.
Mm-hmm. It's not like you have different prefix, like a route distinguisher, you have different prefix belonging to different
Yes,
different
it's
client.
not a different, yeah, that's not it. It's correct. Yeah, it's the same prefix, yes. Correct.
So in a way, it's almost like the TE, you want different path, like different prefix, you want specific path. Isn't that same as the SRTE, same thing?
Yes, exactly. It's a state of art. That's what we want to, it's a notion that is used in the SRTE today, and we want to carry exactly the same notion when we do a distributed mechanism through BGP, because that's exactly the same idea.
Okay, thank you.
Anybody else brave enough to risk the cutoff?
Not, I believe we are done. Up, there's one coming in.
Kaliraj, you have the mic.
Yeah, I was just expanding on Linda's question. I think she's trying to ask if it is the same as SRT, why do we need a new FSRP?
But SRT is for today, it's to talk to SRPC. This is a BGP way of advertising the intents. So in BGP way, but we still want to keep the construct of color so that all the mechanisms we have developed in the past for the interworking compatibility, everything works. So we still want to keep the notion
Is
central
that
to
to say
color.
that SRT, so basically if I understand it right, SRT is not extendable enough so that it can work between BGP speakers?
Can you repeat that, Kaliraj? I didn't follow.
So are you saying that SRT is not extendable enough that it can be reused between BGP speakers? It's only between a controller and a speaker, and we need a new family between a BGP speakers.
Yes, so there is no mechanism for the SRTs with a PC way, not through BGP. There is a SR policy which can be downloaded. It's a policy that downloads the head end. In this case, we want to advertise distributed way an endpoint address through the hop by hop mechanisms. So there's no such mechanisms today. And as we are talking about this, as we saw the problem statement and the solution for it, we just want to use the semantics about endpoint and the color as it was used by SRT, so that the notion remains exactly same as we already discussed. It's about going over particular intent aware path, which today, which is well deployed is through SRT. We want our services to get steered exactly same way. It just now it's another solution is using BGP card, and they should interwork and should work together. Yeah.
Thank you.
Wim, you have the queue.
I just wanted to add, I think it's important to analyze this space in its totality and see how we best address that solution to the problem. I think that would be my recommendation, is that we would look at the different aspects of what we want to achieve and then see how we best solve it given the capabilities that we already have developed. So I think it's important that I think what I understood is that there is already a discussion between the different the people from the different car proposals, because there are a bit of competing proposals, that we work together and try to find out a common ground going forward. I think that's important.
Yes, sure.
Yeah.
I see nobody else in the queue, and we are 8 minutes after the hour.
Then start tomorrow. We have a session on Wednesday. So we'll see you all on Wednesday. The session is, and I'm outside of my normal place, just a minute. Well, go ahead. We'll see you tomorrow. I believe we're at the second session tomorrow. Thank you. Kayer, do you have a list of when we're at Hague time tomorrow? I'm just not pulling it up real quick.
Yep, I do.
What time is it, Kayer, that we're on tomorrow?
I believe we have the same time, I believe so. Actually, 14:30. I want to say 14:30 Universal
to
Time.
15:30. That is
Yep.
correct. Thank you very much, all. Thank you for the excellent discussions. We'll see you tomorrow at 14:30. I hope you have a good rest of the day virtually on Prague time.
And Sue, I think the test instance for MeetEcho might still be accessible if you look through your archives, so we can maybe see what it'll take to get you to full screen display on top of your desktop.
Is it just at the general? Where do you go for the test sequence?
I would have to check my mailing list archives, but I think the mail was sent to the working group chairs at some point prior to the session.
I'll find it. Then I've got my MeetEcho. Let me save the mail list, and then I'll go pop over there.
And
Thanks.
they haven't kicked this off yet, so if you want to just give it a try, we can maybe take
I'll
this
give
time
it
as
a
well.
try. Let me see if I can share my screen. I've got a presentation. Let's see if we can get to it. I was share screen. Yes, I really want to share my screen.
At least on my Mac, I had the option to also share an application rather than a screen, but I was screen sharing.
I tried the application sharing and that didn't work.
Okay.
What do you think? Do you see the application? Hold on, we'll grab the PDF. That was
So
the
now
wrong
I'm
one.
actually seeing a Word
Yeah,
document
this is
that's filling
pretty
the screen.
The Word was fine, but the PDF didn't. Let me see if I can stop sharing and try sharing again with the.
What are you using to display the PDF?
I'm using Acrobat, Adobe Acrobat PC, which is why I tried. I was downloading that last night. And
Jeff,
that
were you
usually,
using preview?
I was using preview on the Mac, but
Yep.
I was also using full screen.
Yep. That's what I
how
have.
is now? Do you see it now?
Nope.
The full screen?
Nope.
It's not even loading.
Oh, that's really good. Let's try application window. Nope, not loading my entire screen. Now I get the sort of windows.
Yep.
Okay.
But
not
this is
the
window
blend.
inside window.
Yeah. Okay.
But Sue, for the next session, either Jeff or me, one of us can always share the screen if you want.
Okay, that's why I set up the slides the way I did. I've got to remerge the slides and send it to you. I'm gonna go try to talk to the MeetEcho guys and figure out why. I tried last time. I used Nuance PDF shower, but that I thought the Acrobat would be more commonly used. So I don't know what happened. So for the second,
sorry, I was
So-
going to say I got to bail unfortunately for the LSPR meeting, which is next.
yep. Talk to you later. If you would plan to share your slides, or Jeff, did it work well sharing the slides for you?
I had no problems sharing the slides. I have two displays. I was running one display with the slide share. I was running the second display where I had the MeetEcho console, so I was able to see and manage the mic queue.
Okay,
So
that sounds good.
yeah, Jeff, if you want, I can do it tomorrow, or if you want to do it again, that's fine as well. You let me know. And
I'm happy having you do it. So why don't we plan on you doing it tomorrow, Kay, unless Sue can figure it out?
Okay, super. Perfect.
We'll plan on that. I'll send you out a new set of slides. I'll be over in LSR in just a moment as I'm
Super.
helping. Bye-bye.
See ya.
Later.